Hey everyone, so we are doing this question called rotate array, and we're given an integer array. We have to rotate it k steps. So brute force solution for this would be, let's say we have to rotate an array 3 times. So we're going to rotate it once, we're going to rotate it again, and then we're going to rotate it again. So what happens to the time complexity then? It becomes, since we're doing k rotation, and in every rotation we are doing n, we are actually rotating the array. So every element would be shifted by one place. So that is why we are having n operations in a single iteration. So my time complexity becomes k into n. And this is not a very ideal way to do this. So then instead what we can do is, let's say, but before that we have this observation. Let's say if my k is greater than n, do we really need to rotate k times? We'll come to this. So let's say if I have an array 1, 2, 3, 4, and let's say I rotate this 4 times, and my k is 4. So what happens if my k is equal to the length of the array? So let's say we rotate it once. So when we rotate it once, what happens is my 4 comes here, shifted by one place, and this is how my array looks like. Now let's say I rotate it again. So now my 3 comes here. So let's say we rotate this again. So what happens is my 2 comes here. And let's say we rotate this again, 4 to 4 times. So I get back my original array, which is 1, 2, 3, 4. So you notice that when my k is equal to n, I get back the original array, which means essentially if my k is greater than n, we only need to rotate it by k mod n steps, k mod n times. So if my k were 7, it would basically, and my n is 4, it would basically mean that for the first 4 times, we would get back the same array, and my remainder is 3. So it basically means that we have to only rotate thrice. So this is the main logic of this problem. So let's do that here. So let's say my int n is equal to numsert length. Now what I'm going to do is, we are having this k. We're going to update k to k mod n if my k is greater than n. We don't need to rotate it more than the length of the array times. So then we have this question which says that we have to use constant extra space. So if this were not a requirement, we could have an array buffer and then we could swap it. I mean, we could place the element at the correct index. But since we have this, we're going to use a technique which is, you know, rotation symmetry, which basically says that there's a trick to solve this question. The first step is reverse the entire array. The second step is reverse first k elements, then reverse remaining elements. Reverse n minus k elements. And this works. Why does it work? I'll tell you why. So let's say we have this array called 1, 2, 3, 4, 5. And let's say my k is 3, which means I have to rotate this element 3 times. I mean, rotate this array 3 times. So ideally, my 3, 4, 5, which is the last chunk of element, it would go to the front. And my 1 and 2, which is the first chunk of element, it would be shifted to the right. Now you see this. So let's say we divide this into 2 blocks. My first block, which is this chunk, after rotation, this will come here at the front of the array because of because we don't have space after this. So it's going to go to the front. And then 1 and 2, which is my first chunk, it will come to the end of the array, which is shifted to the right. Correct? So this is how after rotation looks like. So let's say if I were to say if we had 2 blocks, let's say if I take this array and let's say I have 2 blocks, let's say A and B. And B is the block that will go to the front after rotation. And A is the block that will come here after rotation. You see what is happening? We need to mirror the index. So that's why our first step says that we have to reverse the array. So what happens after reversing the array? Let's say our start looks like we have two chunks. We have A and B. Then when we reverse the array, our B comes to the front, but in a reversed way. And then A comes after that, but in a reversed manner. So what will happen is, if I have 1, 2, 3, 4, 5, and K is 3, then what will happen is, after reversal, we would have 5, 4, 3, followed by 2, 1. But we want 3, 4, 5, and 1, 2, which basically means we have this in reversed order. Now we reverse the first k elements. So what happens after we reverse the first k elements? We are going to get what? So when I reverse the first k element, B reverse. So if we reverse the array twice, we are going to get back the original array. So that's why we get B here. We get back B. So when we get back B, we have this 3, 4, 5. Right? And then in the third step, what we do is we reverse n minus k elements. So when we reverse n minus k elements, what happens is, from this, we are going to get A reverse. And what is a reverse of A block? It will be A again. So we got B and A. So was this the answer we are looking for? Yeah. So this is where our last block will get reversed, and we would have 1 and 2 here. So this is the entire correct, and this is the correct answer we are looking for. So this trick works. So what have we done here? We basically reversed all the elements first. So my start index is 0 and end index is n minus 1. Then what we have done is we have reversed first k numbers, which is k minus 1 would be the last index for first k numbers. Then we have reversed last remaining numbers. So it should be starting index k up until n minus 1. So this is what we have done. So let's write a helper function called reverse, which is going to take an integer array nums, and it is going to take a start index and an end index. Now what happens is, while my start is less than equal to n, or let's say start is less than n, I'm going to have a temporary variable which will store nums of start. We're going to swap numbers at nums of start and end. So nums of start would then be nums of end. Since we're swapping the values of nums of start and end, and my nums of end would be nums of start. Sorry, 10. Since we have cached the nums of start value to temp here. Now I'll do n minus minus. So let's do that in place here, and then we'll do start plus plus. So yeah, this is the entire code, and let's submit this. So the time and space complexity is my time complexity is big O of n. Since we are reversing the first, we are reversing n numbers, then we are reversing k numbers, and then we are reversing remaining numbers. So our time complexity is big O of n, where n is the number of elements, and our space complexity is big O of 1, which is constant, since we haven't used any extra dynamic data structure here that scale with the input. So yeah, this was it from my end. Thanks for watching. Bye.